Ionizing radiation consists of subatomic particles or electromagnetic waves that have energy to ionize atoms or molecules. There are two types of ionizing radiation, which is the first one is directly ionizing or charged particle, and the second one is indirectly ionizing or neutral particles. This is for the first one for direct ionizing, which is this is alpha particles. This is before the alpha decay process. And this is the product of alpha particles after alpha decay. The second one for direct ionizing, which is beta particles. This is the process of beta decay. And this is the product from beta decay, which is beta particles. This is the first one for indirect radiation, which is photon. Photon is a tiny particle that have no charge, no resting mass, and travel at speed of light. The second one is neutron. Neutron is a subatomic particle which have no net electrostatic charge, and it is very similar mass to the proton.
So there is type and characteristic for non-ionizing. Non-ionizing radiation is described as a series of energy waves composed of oscillating electric and magnetic field traveling at the speed of light. Non-ionizing radiation include the spectrum of ultraviolet, visible light, infrared, microwave, radio frequency, and extremely low frequency. So the first is extreme low frequency radiation, ELF. ELF radiation at 60 Hz is produced by powerless electrical wiring and electrical equipment. Common source of intense exposure include ELF induction, phone case, and high voltage power lines. The second is radio frequency and microwave radiation. Microwave radiation is absorbed near the skin, while radio frequency radiation may be absorbed throughout the body at high enough intensity. Both will damage tissue through the heating. The source is include radio emitter and cell phones. The third is infrared radiation. The skin and eye absorb infrared radiation as heat. Workers normally notice excessive exposure through heat sensation and pain. The fourth is visible light radiation. The different visible frequencies of the electromagnetic spectrum are seen by our eyes as different colors. Good lighting is conducive to increased fluorescence and may help prevent incidents related to poor lighting conditions.
Application of ionizing in industrial and medical field. First, food irradiation, medical equipment, and other substances are exposed to certain type of radiation to kill germs without harming the substance that is being disinfected. When treated in this manner, food takes much longer to spoil, and medical equipment are sterilized without being exposed to toxic chemical and extreme heat. Next, gauge contain radioactive material that emit radiation, and it used to measure the thickness of paper product, fluid level in off and chemical tank, and the moisture and density of soil. Diagnostic radiology to produce image of anatomical internal structure of human organs and functional biological systems. Next, radiation therapy utilize ionizing radiation to treat malignant and benign diseases. Radiation therapy works by exploiting radiological differences between cancer and normal cell or tissues, and by depositing radiation dose in cancer tumors while keeping doses to surrounding normal tissues below damaging threshold as much as possible.
Application of non-ionizing radiation in industrial and medical. First, for industrial is ultraviolet or UV used in forensic. UV is an investigative tool at crime scene to help locating and identifying body fluid. Second, use infrared in night vision, used in night vision equipment to see at night. In medical, used in laser surgery, use special light beam instead of instrument for surgical procedure. Second, use in medicine. Non-ionizing radiation use medicine for diagnostic and therapeutic purpose.